All right, everyone. Here you go. Lesson is going to cover chapter 8.3 in the textbook. I hope you're doing well, that you're still safe, and you're able to keep, keep focused and keep up with the work. By now, you're probably going haywire. I don't know. Who knows? Maybe this will, take your mind off of the fact that you are really, really feeling that cabin fever. Let's do this. Surface area, right here, and volume of prisms and pyramids. I am actually going to be focusing a lot more on the volume of things because essentially surface area is composite shapes. As an example, I am assuming if you've had enough practice with composite shapes in the previous section, you should be able to work through formulas that involve surface areas. So here, as an example, I'm trying to draw me a nice rectangular prism. In your head, you're gonna have to assume that that's perfect, okay? As an example, let's pretend the height is like 2, the width is like 6, and the length is like 12 or something, okay? If I were to ask you for the surface area of this rectangular prism, what would you do? Well, as opposed to looking at a formula sheet, I'm hoping that you're able to identify that the surface area is essentially, you're adding the area of 6 sides. What is the area of that rectangular piece? Well, assuming that you know the area of the long piece is length times width, because it's a rectangle, it would be 2 times 6, right? What about the other piece? What about let's give it a different color. How about the side piece, right? The side piece is another area of a longer rectangle, but in this case, the length times width would be 2 times 12, which gives us 24. And the last side I want to discuss would be, the piece on top, basically the roof of this box, right? What would the area of this be? The area of the larger rectangle is going to be, again, length times width, which is 6 times 12, so 72. The gray, the blue, and the pink sides need to double up because if there's a side on the top, there is a side on the bottom. And if there's a blue side on the front of this shape, right, there's going to be a side that you can't see. And the gray in the front, there's obviously going to be side in the back. So if you were to take the 12, the 24, the 72, multiply each of them by 2, and then add it up, doesn't that sound familiar? It's basically composite shapes. This is why I am going to not focus on surface area in hopes that you can use your brain, think critically, think hard, think creatively, and find success in finding surface areas of any kind of shape that I give you. Except, of course, some of the fancier shapes like, what's the surface area of a sphere? That's not a composite shape. Don't worry. I totally understand you using a formula for that. Okay? So when we get to formulas for volume, which is the focus of this video, it really gets really, really interesting. Okay, so my goal is to get you to not memorize, because anyone can do that. Okay, my goal is to get you to try to see the brilliance of how we even got those formulas in the first place. Okay, so it's a bit of a story. If you want to follow along with me, bust out a piece of paper. If you just want to listen and see where the formulas for volume comes from, great. Okay, I'm going to clear up some space because we don't need any of this. If you wanted to copy it, well, go back and pause the video. Okay, so here is my explanation for volume. This video might be a little long, so I don't know, go grab a snack, grab a cup of water. Okay. Take, for example, a 8.5 by 11 inch piece of paper. Okay, what's the area? what is the area of a rectangle? Because it is a 2D shape after all. It's length times width. 8.5 times 11. Do it on the calculator. I pre-did that. It's 95.3 inches squared, of course. Well, what if I asked you for volume? Well, it's a 0, right? In grade school, you might have looked at that. Let's explore, right? A volume is a 0 because this is a 2D object. Let me give you an example. I'm going to take this piece of paper. I'm going to lay it flat on the ground. So this is 8.5 inches, 11 inches. Volume is going to be length times width times height. So in this case, length is 11, width is 8.5, and what's the width? What's the width of a piece of paper? Well, height. Oh, sorry, what's the height of a piece of paper? Height is virtually 0. So if you multiply by 0, what do you get? You basically get 0. This is why volume does not exist for 2D objects. But here's the interesting part. When you buy paper, does it have a height of 0? No, because when you buy paper, it comes in a stack. So what if we stacked it, right? What if we took a piece of paper, so that's my piece of paper, and I stacked 2 pieces of paper together? Is there a height? Nah, it's still very close to 0. It's not even 1 millimeter, right? But what if I stacked 3 pieces of paper? Is the height still 0? Yeah, I guess you can argue. But what if I stacked 500 pieces of paper? In other words, what if I had a ream of paper? And I know everyone knows what that is because I'm sure you've seen a printer, okay? Or you've bought paper, or you've seen someone buy paper for printers, and they come in stacks of 500. That is a ream. Fun fact, okay? 500 pieces of paper. If you buy a ream of paper, that is approximately 2 inches. So 8.5, 11, and a height of 2. What is the volume for a ream of paper? 8.5, 11 times 2, which is approximately, well, double 93.5. It would be 187 inches cubed. So what does that 2 actually do for me? Right? Where's that coming from? Long story short, volume, the height, is basically a bunch of 2D objects stacked together. Okay, that is a bunch of 2D objects stacked. Okay, in other words, volume is equal to area of 2D object times the stack height. Now we're getting a little too technical, and some of you I might have lost already. Long story short, the idea is sort of like a strand of hair, okay? One strand of hair is too thin. Can it hold anything? Like, can you use it to hold, I don't know, a sign up at a store? Can you use it to, pull yourself up in a mountain? Absolutely not, it'll just snap. But if you have enough strands of hair, you can actually create a rope out of it. That sounds a little scary, isn't it? Try not to think about it too gross. Think about like Rapunzel, right? Like let down your hair, as opposed to letting it down. That dude that was climbing that tower probably would have done a better job if the hair was actually braided. Anyways, stupid example. All right, let's move on to the lesson, okay? Yeah, I know some of you missed my stupid stories. I know it. Let's get to it. I'm going to use the same idea of this ream of paper for cylinders. Let's pretend you had, for a cylinder, let's pretend you had, just to prove a point, instead of just a cylinder, maybe you had like I don't know, some kind of disc or a super flat piece of paper that you cut as a circle, and you stacked one on top of it, 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 all the way until it actually created a certain height. So this cylinder can actually be just a whole bunch of 2D objects on top of each other. And what do we say the volume was? It was the area of the 2D object multiplied by the height. In this case, what is the 2D object? It's a circle. So what is the area of a circle? Pi r squared multiplied by the height. Go on Google or take a look at your formula sheet, maybe in your agenda. You'll see that the volume of a cylinder is pi r squared height. Surprise! The same can be done for triangular prisms. Okay, so again, if you are able to figure out the area of the triangle, and we pretend that a whole bunch of 2D triangle piece made out of pieces of paper are just stacked on top of each other, the volume is going to be the area of the triangle multiplied by the height. Okay, and what's the area of a triangle? It's the base, let's do a different color. It's the base of a triangle multiplied by the height of a triangle, right? And of course that would be, I don't know, it doesn't, yeah, it would have to be 90 degrees. So half base times height multiplied by the height. But you see how that could be confusing? There's a height here and that's a height there, and those are two different numbers. So this would be the height right here, would be the height of the actual 3D object, but that's the height of the triangle. So some people might simply write this as length. What's the length of this volume shape? Okay. Why am I talking so much about volume? Well, when we get to things like prisms and cones, right? For example, if we get to things like pyramids, okay, or we get to cones, this and this are essentially pieces of a 3D object, right? A pyramid, you can say, is actually a rectangular prism that I shaved off. I shaved off the sides until I got a nice pyramid. And same with the cylinder. If I take a cylinder, let's say if you take woodshop class, you know what I'm talking about. If I take a cylinder and actually use a machine and shave off all of the sides, I can create myself a cone out of it, right? The question is, how much are you shaving off? In a quick second, I'm going to erase it to sort of continue on this conversation. Before I forget, I'm going to shamelessly plug in your homework. Page 441, questions 1 to 5 are fundamental questions. They're like the bare basics, right? Try them and then challenge yourself with numbers 6 to 14 because those are sort of the test level style questions. You have to get to both of them, all right? So pause the video now if you want to take any notes or copy any images down. But I'm going to clear this image and go on and talk more about this stuff in 3, 2, 1. All right, let's get to it. So what if I have a prism, or sorry, a pyramid or a cone? So how do I get the volume of a cone or a pyramid? This isn't a 2D object that's stacked together. If anything, let's say I was talking about a cone, I would have a 2D piece of paper, circular piece of paper, stacked by a smaller circle, stacked by a smaller circle, stacked by a smaller circle, stacked by a smaller circle until I get a cone shape. And that's annoying. Okay. I'm going to go so far as to say that the volume of the cone was actually not, we weren't able to calculate that until we developed in human history, more advanced sort of like grade 12 math, okay, and like calculus and change of rates and blah, blah, blah. But what I'm going to say is this. Anytime you see a volume of a cone or a prism, the golden rule is your shape, the volume of your pyramid or cone is 1/3 of the 3D object that it came from. I'll say that one more time. The cone, let's say, let me erase this. The cone, please remember that previously I said a pyramid is basically, let's use a different color, is basically a shape that can come from a rectangular prism, right? What is the volume of a rectangular prism? So volume of a rectangular prism is length times width times height. Big whoop. The volume of a pyramid, which comes from a rectangular prism, right? You can fit it in, is 1/3 of the volume of the shape that it can come from. In essence, it is 1/3 of length times width times height. I'll let that sink in. I'm going to give you another example. In the same way, this cone right here, what shape could it come from? Going once, going twice, it could come from a cylinder. If I take a cylinder and I shave all this excess parts off, right, I would get a cone. So the volume of a cylinder is, remember it, pi r squared height, the area of a circle times how high it's stacked. That means the volume of a cone is 1/3 of the cylinder it came from. And it's really interesting how that is shared amongst all things when it is sort of shaved off from a larger object. Okay? Again, this might not be interesting to you, and you might just say, I'm just going to memorize it. Fine, that's okay. Most likely, if we do get to an exam, you will be given a formula sheet for this. If we ever do EQAO, you would have definitely gotten a formula sheet. But long story short, understanding where these come from and the creativity and sort of like the connection between all things, understanding that it's not just some made up formula, but there's actual logic behind it, really sends your understanding and your level of critical thinking to a new level. Please don't just memorize, but really consider how these pieces come together, because there's a lot more of this kind of quote unquote magic that you might see in the future. Okay? As a reminder, once again, your task is page 441, numbers 1 to 5, because it's just fundamental questions. And the same page, numbers 6 to 14, would be your real challenge in your test, because those are the kinds of questions I would throw in on a whim on an evaluation. Your very best. A problem set is on the way, so make sure that is done. Yeah. If you have any questions, please. I'm starting to see slightly less activity. Please keep trucking, keep on going, people. You can do it. You won't regret it, especially next year. I will see you hopefully sometime soon. Take care.